Hi, everyone. My name is Yolanda Davis. I am an Apache NiFi committer as well as PMC member. And today I'm going to talk to you about how you can leverage a rules engine within Apache NiFi or within the context of your flows. Normally, if you ever seen any of my demos, I normally jump right into it and show you a flow. But today I want to walk you through a bit of concepts first before we actually dive into the example. All right, here is what we will cover today. So the first thing is we're going to discuss what rules engines are. So what is a rules engine? Why would people choose to use those versus embedding some of this logic within their code? The second thing is we'll talk about how we can use this within NiFi. So what are the potential use cases where you can leverage a rules engine? Next, we'll go into the classes that support rules engine functionality within NiFi as well as the APIs, so specifically the rules engine service. We'll talk about how you'll need to access the libraries for a rules engine. So it's not available in the download binary or the binary that you can download. So we'll talk about how you'll need to build NiFi to ensure that the rules libraries are available. And then finally, we will dive right into the rules example where we will be doing some routing and alerting using a rules engine. So first, what is a rules engine? Well, if anyone has ever read any articles or some of the books from Martin Fowler, he describes a rules engine as something that's based on a production rule system, where you have some notion of a set of rules, and every rule has some condition as well as some consequential action that needs to take place if a condition is met. So for example, if we were to create a rule for NiFi, we can look at what is there on the right-hand side. We can say, hey, if a flow file size is greater than, I guess it's 100,000 bytes, then we will want to log some message. So that in of itself can be considered a rule. And if we were to break down that rule just a bit, it would consist of three main things. The first thing is you have a fact, which in this case is our flow file object. That's the object that's going to be interrogated by the rule. The next thing is you have a condition. So it's going to be something that is checked or some logical check that needs to be met. And in this case, it's checking the size attribute of the flow file to see if it's greater than 100,000 bytes. And finally, the action that is triggered, which is, of course, the warning of, uh-oh, maybe our size is too big or bigger than what's expected. So all of those things together define what a rule is. And you could say, why would I need some kind of special or separate system in order to manage this? Well, some use cases are you might not want to have these particular conditions or these particular rules defined in your code because maybe they change often, or maybe someone else is in charge of managing those conditions and they might not be the person that's administrating your system, or they might not be a developer in your system. So those are a lot of cases where I've seen or I've encountered a rules engine. So here's it's a pretty specific or a very simplified example, but definitely look into more about rules engines or production rule system by going to the link that I have below, shown by Martin Fowler. So what are the reasons or why would we want to use a rules engine within NiFi? What could be some of the things that we can do to, empower our flow to be a bit more dynamic? Well, one of the first things are routing and filtering. So perhaps you might need some messages if they meet a particular condition, routed in one place or filtered out for some reason. And those conditions are something that's managed by an external system. That's one place or one way you can use a rules engine. Decisions to make about logging or alerts or notifications. So if I encounter something within a particular flow file, or there's some, multiple things that I'm checking within a flow file and its attributes that necessitate the need to log or send some alert, we can use it there. Also, data transformation or some type of enrichment. Maybe there's some change to data we need to do. Maybe we need to update attributes. And in fact, NiFi already has a processor called update attributes that does the same thing. It has a concept of rules. You define a rule there, one or more rules, to highlight what conditions that need to be met, and then you apply some particular action to update an attribute. So that's one type of example. But a rules engine may be useful to help make more complex decisions, as well as perform more rich transformations or enrichment or adding data if needed. So here is just a quick description of the classes and the APIs that come within NiFi to support integrating a rules engine. The one thing to keep in mind is that rules are very much user defined. So you won't find hard-coded rules or actions within NiFi itself. These are things that can be defined by those administrators or those who are involved with defining the workflow. And then the rules engine service would leverage the classes that have these user-defined rules and actions. So just to break this down a bit, the rules class itself, that's what we use to help define the classes that should be evaluated. So what particular objects or what particular metrics or variables that should be available that the rule will need to access in order to test the set of conditions. The rule also has a defined set of actions. So if we find out that the conditions have been met when it evaluated those facts, there's one or more actions that rule will define that says this is what needs to be performed. Of course, the action class itself, it's very generic in the fact that it gives the ability to define here's the type of action that should be performed and the required attributes in order to execute that action. So we'll see how that is implemented in just a bit. But the key with this is it's a way for your administrators and those who are in charge of kind of flow design or workflow design to be able to loosely define or what makes sense for them and what rules need to be implemented and the types of actions that should be performed. Because the job of the rules engine service, which is kind of the interface, the job of the rules engine service is to be able to receive facts and then send back what action should be performed. So that is what is a bit of a differentiator. You'll see some rules engines, they will execute whatever actions. In this particular case, the rules engine service will return, here are the actions that should be performed. And that way the caller will be able to receive those actions, look at the type and get whatever attributes needed to execute that action and perform the work. So it allows the NiFi flow to decouple what processor or what component will make a determination of what should happen using rules engine versus what component is going to actually do the work. That's how this API is defined. All right, so I mentioned this at the top where I said, here are the things we're going to go through. One of the important things with the Rules API is that the default implementation of the rules engine, which is backed by EasyRules, there's a link right below that shows you how to find out more about EasyRules. But that default implementation is not part of the binary download for NiFi. So for those of you who are really, really brave and want to download the source code for NiFi, check out the 1.10 tag and compile it yourself. Right here are the instructions on how you do that. You'll use what's already been documented in our quick start link on the NiFi website. I'm showing that at the below too, but you want to be able to build, but also add the profile, include rules. And that will make sure that you'll have all the libraries you'll need in order to give this a try. All right, here's the part you've been waiting for. Next, we are going to walk through a flow that leverages the rules engine controller service as well as the invoke scripted processor in order to do some routing as well as create some bulletins or some basically logging messages and see how we can put all these things together. All right, so here is the flow that we are looking to execute with rules. So as you can see, we're using just a couple of basic generate flow files. One of these processes will be generating a flow file of like a 1 byte size, and the other one larger than a byte, maybe 2 whole bytes. And then we're using an invoked scripted processor in order to, which will actually call the rules engine, sending information about that flow file, excuse me, and then understanding exactly what it should do or what actions it should perform in order to making a route decision or logging a particular error or warning. And then finally, we have a kind of the downstream components that very simply have just a log attribute, but just focus on the particular relationships that are defined for this processor, small and large. And remember that coincides with the, or correlates with the rules that we have defined, or the routing information that says, hey, if we have one of a certain value, the relationship should be small, otherwise it should be large. So just to dig in a little bit, let's see how we have first the EasyRulesEngineService configured. So if we were to go into, you saw I went into the configuration settings, and then specifically the controller service tab. I already have an EasyRulesEngineService defined and set up here. So looking at the configurations, there's 3 basic things that should be set. One of the first things is what is the file type that you're using. In our case, we're using a YAML format file. Here's the location of that file. We'll go through a little bit what the rules file is and how it's formatted, or how you specify those rules, because that's what EasyRules supports, providing our rules definition as a file format. And then finally, we have a specific format for NiFi. So in the case of this EasyRules controller service, it uses NiFi rules as well as EasyRules format, using Mevel or the Spring Expression languages. In our case, we're using NiFi, so we'll dig a little bit into that as well. If you want to see more documentation on what those file formats are, you can go into the usage menu, like you saw me click there, and go into additional details. And so it will go into detail of what the NiFi rules format is and provide some examples. But today, we'll talk through the example that we're using for the routing rules. So I have a little gist here set up. This will hopefully be clearer than showing the actual file that NiFi is referring to. But here is how we specify those routing rules using a YAML file, and specifically the NiFi rules format. So basically we have 2 rules defined, one that will perform some action if it's a small float file, and the other one that will perform some action if it's a large float file. It has a description, the priority in which these rules should be executed in the engine, as well as the condition that should be checked. And again, and the NiFi format, it supports the Mevel expression. So you see an expression that wants to check a provided flow file size attribute and to see whether or not that's less than or equal to 1. In this particular rule, we have a couple of defined actions that we want to perform. Now, the key with actions is that it's user defined. It's not something that's hard coded necessarily in NiFi. It's basically something that the user can define, and whatever is calling it, it needs to be able to understand how to read those actions and how to perform those actions and interrogate the attributes. The reason why this is more of a NiFi format is because an action is specifically defined given a type as well as attributes. So when we use the easy rules, they'll have just a basic expression that should be executed. But in this particular case, we want to have a type and attributes so that a handler will know if I receive an action type, what are the particular things that I need or attributes that I need in order to execute a route type. Same thing for logging. And in this particular case, you see we have 2 actions. We say we want to have an action of route, so it'll know to route to the small relationship if this condition is met. And we also want to log, and we want to log a particular message with at a particular log level.
And so finally, the rules definition also includes a fact. So what are the actual facts that should be included in order to execute this rule? And in this case, we're just going to look at a flow file object. And so that same structure is available for the other rule as well. Just notice the difference, of course, is in the condition that's being checked, but also in the fact that it's only one action that's going to be performed. And in this case, we only want to route to the large relationship. So finally, let's look at the particular script that's going to be behind it. So I had already mentioned, or I think I mentioned, that we're using an invoked scripted processor. Right now, we only have the controller service in the community. There's no particular processor that knows how to interrogate it. So there's an invoked scripted processor. If anyone has never used an invoked scripted processor, that's a great blog that gives you lots of different use cases. I'm showing the link below of Matt Burgess, who's also a contributor to the community and PMC member. He writes great articles on how to use lots of scripted processors, and invoked scripted processor is one of them. So if we look at this particular configuration, I'm using the Groovy script engine in order to write a script that knows how to call the rules engine as well as how to handle the actions. It's a little hard to see here, so I am going to also again use gist in order to show what we have defined. So here is our route rules processor that's scripted. Of course, it defines a property for the rules engine, so that basically allows us to configure the EasyRulesEngineService so that it can leverage that. Also, it has those relationships that we define in rules, so it understands small and large as a relationship or a connection to figure out where to route our flow files, as well as a relationship in case anything goes wrong. We hope it doesn't go wrong in this demo today. And then finally, we have this section. I want to focus on this section here that will actually interrogate or call the rules engine itself, sending the flow file information as a fact and knowing how to handle it. So as you can see, we are taking the flow file that we're getting, and we are adding that as a fact. That fact is getting sent to the rules engine or the list of facts. So facts are really sent as a map of facts, with the key being the attribute, or the key being the flow file. So that's what the rule expects to come in, and then the actual object itself. So it's sent as a map of objects. The rules engine is executed with those facts, and it returns a list of actions. So from this point, the scripted processor will be able to look at each one of the actions that comes back and actually perform the action itself using the action type as well as the attributes. So for example, it knows if it gets an action type of route, then in this case, it will set up the relationship or ensure that the relationship that will be used to send the flow file forward will be appropriately set. So in this particular case, if the relationship sent back from the attribute is small, it'll go to the small relationship. Same thing for large, it'll go to the large relationship. And that's all defined by the rules that are returned. Same thing for logging. So if we are iterating through the actions and we get an action that said we should log, it'll get the message that should be logged. I kind of cheated a little bit. I should have also interrogated the attributes. You can do that as well in order to get the logging level. In this case, I'm just hard coding warning, but you can actually get it from the attributes as well. And then finally, our dog wants to contribute to this as well, but finally, the flow file is returned with the appropriate action. All right, so now that we've gotten our dog to stop barking and enjoying our presentation, we can finally see how all of this comes together. So in our particular case, we're gonna have two different generate flow file processors. They're going to create flow files of a different size. Both are going to come in, be evaluated via the rules engine using the invoke scripted processor, and hopefully be routed accordingly. So I'm going to not cheat. We're going to clear out this previous run by emptying the queue here so that we can really see how all this is coming together. I'm going to empty this queue as well. So our expectation, of course, is that our small flow files will go to the small route. Large flow files, anything above 1 byte, will go to the large. And I'll actually won't start this whole flow. I want to make sure that our log attribute doesn't start, so we can just see these files land in the appropriate queues. And let's go ahead, start things up and see where things land. So as you can see, we have things already routed appropriately, and we're seeing some warnings come up, right? So those are the warnings about the small flow file. And just to kind of double check, let's go into the queue itself and see what we have. So we're going to list the queue. Refresh just to make sure. All right, so this was probably what's coming through right now. We'll go ahead and read the information, the details on it. So in this particular case, we have a file size of 2 bytes. Remember, this is the large connection over large relationship. And that's exactly what we expect to get routed. In the other case, let's go back and list the queue for the small. When we look at the details here, we have a file size of 1 byte. And again, you see that those bulletins are being posted. So that's kind of how all of this can come together from our rules definition, having a script that knows not only how to call the rules engine, but also how to handle the actions, and the flow coming together and operating as we expect. So some of the things that are currently in master, not necessarily as part of 1.10, but things that have been contributed to the community since the Rules Engine Service API was contributed. Here's a few things. So first, there are going to be some action handler implementation. So an action handler interface is available as well. We didn't go into detail today, but this allows you to use some other class as opposed to writing specifically within a processor or a scripted processor, allowing some other class to handle that action, whether it is an alert or log like you saw there in the demo, or to use the record sync. So if you're not familiar with the record sync API, you want to send it immediately to some downstream repository or some other service. Or if you want to execute the expression that's returned, so whether it's a Mevel expression or a Spring expression, these are handlers that can help processors or the other components to handle or execute those actions. Also, there are some scripted versions of not only the rules engine, but also action handlers. So if you don't want to use EasyRules, if there's another rules engine that you want to connect to and leverage, the scripted rules engine will give you that flexibility, as well as the scripted action handler. That'll be something that provides flexibility if you want to externalize or have a controller service that handles an action for you, as opposed to a processor handling it itself. So these things are currently in master. If you want to be brave and check out the master version, do the build to include rules, and you'll have access to all of these elements. And that's all that I have for you today. If you have any questions, you can reach out to me on all the mediums, whether it is Twitter or LinkedIn. I'm Yolanda M. Davis on both of those platforms. Also, feel free to reach out to the NiFi community. Go to nifi.apache.org and go to any of the drop downs for the community blogs, the community email list. People will be happy to help there. Or you can find further details on my blog for NiFi, which is lonify.blogspot.com. You'll see the written version of this demo and find more information on using NiFi. So thank you so much. I really appreciate you watching this video and looking forward to all the feedback that you have.